Good morning, students. So let's start with today's Google Classroom. So today's Google Classroom it is about the paper physical chemistry. Paper number is 8, and the chapter we have to discuss today is thermodynamics. That is part second. The topics we have to discuss today is that is a second law of thermodynamics and what are the different statement of the second law of the thermodynamics. In the previous Google Classroom, we have already started or the I have given introduction about the what is the second law of the thermodynamics. So let's start with today's Google Classroom. So what is the second law of thermodynamics? The second law of thermodynamics states that in a spontaneously occurring process will always lead to an escalation in the entropy of the universe. In the simple words, this law explains that an isolated system's entropy will never decrease over time. In some cases, where the system is a thermodynamic equilibrium or the going through the reversible processes, the total entropy of system and its surroundings remains the constant. And the second law of thermodynamics, it is also the known that increased entropy. It is also the known as increased entropy. Then, what is the equation of the second law of thermodynamics? The mathematically, this second law of thermodynamics, it is represented as delta S universe is greater than the zero, where delta S universe is change in entropy of the universe. Entropy measures the randomness of system or it measures the uh, energy within the isolated system. It can be considered quantitative index that describe the quality of the energy. There are some few facts that cause increase in entropy of the closed system. Closed system, while mass remains constant, there is an exchange of the heat with the surroundings. This change in heat contains creates the disturbances in system, thereby increasing entropy of the system. Secondly, internal energy changes may occur in the movements of the molecules of the system. This leads to disturbances with further causes irreversibilities inside the system, resulting in the uh, increment of its entropy. So this all the are the points about the what is the second law of thermodynamics and what are the mathematical statement of the second law of the thermodynamics. And let's see what are the different statement of the law. There are the two statements on the second law of thermodynamics and which are as follows. These two statements are the Kelvin-Planck statement and the second is Celsius statement. So let's, what is the first? That is a Kelvin-Planck statement. What is this Kelvin-Planck statement? It is impossible for the heat engine to produce network in complete cycle if it is exchange heat only with bodies at a single fixed temperature. So they have given the exception also. If Q2 is equal to the zero, the heat engine produces work in the complete cycle by exchanging the heat with only one reverser, thus violating the Kelvin-Planck statement. So there is a violation of this Kelvin-Planck statement. So then, second statement about this second law of thermodynamics is Celsius statement. So what is this Celsius statement? It is impossible to construct the device operating in cycle that can transfer the heat from the colder body to the warmer body without consuming the any work. In other words, unless compressor is driven by an external source, the refrigerator won't be able to operate. Heat pump and refrigerators work on Celsius statement. So, in addition to this statement, French physicist and Nicolas Sadi Carnot, also known as father of thermodynamics, basically introduced the second law of thermodynamics. However, as per this statement, he emphasized the use of the caloric theory of description of the law. Caloric relates to the heat and cannot observe that some calorie was lost in the motion cycle. So these are all are the points about the statement about the second law of the thermodynamics and the what is the second law of the thermodynamics. So there are the two statements, Kelvin Planck statement and the Kelvin statement about the second law of the thermodynamics.